All right, there's video. Lights. There we go. Oh, that's for party. Yeah, there we go.
I literally just saw your Instagram page today and I thought it was fascinating as a computer engineer myself, so
Yeah, nice.
pretty cool.
Yep. We're trying. We're doing the things.
Yep. I also happen to have extensive knowledge of RF, so
Oh,
I've
great.
built my stuffy nodes in the past.
Excellent. I'm so thrilled. Yeah, so for this meeting, we're going to be trying to just lay out what is the best. I mean, I wrote it down. Hold on, I have to look because I've slept since deciding. Um, Build lists, like a whole bunch of people have tried out a whole bunch of different types of nodes and stuff like that. How do we make the most cost-effective one? What node types are there that we need? And yeah, what are y'all's experiences with the different hardware? Our goal at the end is to walk away with a list of build lists, so that people can buy super cost-effective nodes or super performant nodes for the number of things that we're doing. We're going to try to stay away from a few topics just because we have time scheduled out over the next 2 weeks to handle them. And that's going to be, where do we put the nodes? Try to stay away from a few topics just because we have. Oops, I'm going to just mute you there. No worries. A little bit of echo. Um, so the topics that we're going to stay away from are, where do we put the nodes and how do we run the Internet in a Box slash BBS slash librarian nodes, just because we've got time already booked on the calendar for those. So show up for those. Otherwise, yeah, we kind of wanted to get folks together so that you could ask questions, so we could kind of review what so far we've used as nodes, and the goals of the project, and what else? Also, just get your feedback. Like, there's a bunch of very intelligent nerds with a lot of background. I'm gonna go ahead and mute folks, and you can unmute yourself to like ask questions, note what you got. But I'll mute you because echo and so on and so forth. So yeah, thanks for coming. I figure, 7:03, we'll kind of get started. People are filtering in. And CJ is going to give us like an overview so far of the project, what we've done, and then yeah, we'll go into questions because after we give that overview, I'm sure some people it's their first time. So we'll leave some space for that, and then we'll talk about build lists. And if you already have a build list written down, we'll ask you to just link it in the chat, and then we'll have like a list of lists, essentially at the end, and that's what we need. And yeah. The other thing I was gonna say is there's no stupid questions. Another thing. Oh, hey, gonna mute you there. Just yeah, no worries. It's okay. It's normal video call stuff. So, but yeah. Um, there's no stupid questions. It's okay if you missed a thing. It's okay if there was a detail you couldn't find in the documentation. That's totally fine. Very smart people need help finding their way through all of these details. It's a lot of details. And there's a bunch of very knowledgeable people in the room as well. So yeah, anyway, that's my spiel. CJ, you want to talk about stuff?
Because I'm doing the way that I'm doing is I can't make it full screen. So, but here is the image that started it all. And this project is a collaboration between the Multiverse School, the High Desert Institute, Burners Without Borders, all of whom are contributing a great deal of effort. So big, exciting project. The organizational goals for the High Desert Institute, essentially, this is a nonprofit that is building places where humanity can survive everything that's coming and trying to find ways to help more people survive what's coming. And we are set up with ad hoc groups that are called guilds. The Lore Keepers Guild is working on the library, all the things that we would want to know. And one of the aspects of that project is connecting people off grid without needing to rely on the fragile infrastructure of the internet and the cell phone networks. And so the question was asked at that first project where we decided to start buying land all over the country and building these free lands where anyone can go live for free forever. somebody was like, why don't we build our own internet to connect them so that people can text each other plans and stuff without having to rely on cell phone companies and like the government satellites, and like people had a lot of opinions about why, but it seemed like a really compelling and exciting idea that actually would not be technically impossible in terms of implementing it. And so this is what came from that conversation, the Cyberpony Express, which actually the person who asked the question came up with at the time. And so with doing it in San Francisco, the big idea is to bring together people who know a lot about hardware, about the software, about network strategies for these kinds of networks, which is kind of still an edge case for networking, and focusing on putting nodes, like the money that we're raising, we're focusing on putting at community gardens, these nodes for free. And so it enables anyone to use community gardens as essentially a cell phone tower, essentially like walkie-talkies for texting, right, across these nodes. And so focusing on community gardens and intentional communities and public libraries as places to host these, but also anywhere that it's appropriate if people want to host one. So typically we have these hierarchical topographies of networks, and you have this large single point of failure in the middle, which is also a large single point of control and censorship and spying on people. And it is a single point of failure, so it fails during disasters. It's not just bad because corporations are controlling what you're allowed to do, what you're allowed to talk about, what you're allowed to, you know, how you're distributing important information that people need in order to survive what's coming. All of that stuff is under someone else's control, and if you're at the whims of someone incompetent, something bad's going to happen, right? So how can we take control away from these hierarchical topographies? The answer is mesh networks. So these are more resilient. They function during disasters. Most of the nodes that we're going to talk about today will function indefinitely. They have no functional like limit of how long they can continue to operate once you set them up. There's, you know, decades, most likely. They have individual control. So you're in control of everything that's happening. It's a trustless system. You don't have to trust anyone in between. Everything is end-to-end encrypted, and there are no corporations needed to be able to do this. You don't need to be paying anyone a monthly bill. You don't need to be paying rent to anyone. And we can all just communicate with each other without needing any of that. So in terms of like where does Cyberpony Express fit in with the other aspects of the stack here? The LoRa is the what? It's the physical hardware. Long range is the name, and this is taking up the frequency spectrum that used to be used for 3G. So 3G is over, and that became free for anyone that wants to use it, and LoRa is what stepped in. And so in those frequencies, we now have this technology that allows anyone to build these networks. Meshtastic is the how. It's the software that's running on the device. There are a number of alternatives to Meshtastic, but none of them is anywhere near as big as Meshtastic. So if you buy a Meshtastic node, if you set up Meshtastic on one of these hardware devices, you can immediately talk to people all around you who are already using it. And that's what's key. So there's other projects like Disaster Radio or Mesh Core, you know, that's very interesting. They just don't have people using it. And so it's not practically useful today in the same way that Meshtastic is. It would be great if eventually they could integrate, right? And BBS may be one way of doing that, which we have an upcoming workshop about. But Meshtastic is what we're using because it's already supported all over the world, and hundreds of thousands of people are using it all over the world today. So Cyberpony Express is the why. So we are a nonprofit, the High Desert Institute, that is funding this. So we're able to accept donations and disperse funds and buy these for people and set them up. And it's a project intended especially for helping people to survive disasters. So one of the side effects is that when we have a world where we have just gutted the NOAA, we no longer have people working on storm detection and storm predictions, right? We fired 800 people in charge of weather predictions. We no longer have like the weather balloons are not going up anymore. We no longer have a current model of the weather that we can use to predict what's going to happen next. Where is the hurricane going to land? Where will there be a tornado in the next 15 minutes? We just don't know, like we did a year ago. And so all of those kinds of problems lead to these the need for these alternative systems. And so we should expect, I think, all of those things to continue to get worse. Just like the weather is going to continue to get worse. And so building these kinds of resilient alternative networks that allow us to communicate and distribute important information is vital. And that's the why behind what we're doing. So we talked in the previous workshop about the types of nodes. Mine arrived to DOA, so I finally got the new one. It's great. This is the one that I think we can comfortably recommend for everyone to have to take with you to use for sending and receiving messages. The TDEC Plus. It's not very expensive. And so it's got the Meshtastic node built in. You can see who's around you. It's got a map of where are the other people if they've chosen to enable GPS. Where are my friends? I can then send them text messages. If there's a node on a hill nearby, we can reach each other through that, right? It's a really great device. It's not very expensive. And it makes it really easy to approach this technology in a very intuitive way. And this is linked in the build list, which is posted on the highdesertinstitute.org website. The other one, the one that we gave out to people who came to the first workshop, is sort of the minimal public node. And so this one is a Heltec V3. It comes with a battery. And I've put next to it here the sensor that allows you to include telemetry related to the current weather conditions. And so this, I think, is a couple dollars. And it's very easy to connect. It tells you which pins you need to connect it to on the board, right there on the board. And you'll be able to broadcast weather data if you want. And so you can share the temperature, the humidity, the barometric pressure. And as people do this, along with their GPS locations, it becomes possible to build hyperlocal forecast models where we can say, like, what are all the different parts of San Francisco with the different weather, and how do we predict what that's going to be? Is Carl coming to the party, right? This is such an important thing that we need to know. And so this is something that's already in use for solar farms, in particular across Arizona, where they have these exact kinds of systems set up, forecasting when a cloud is going to come so they can spin up peakers to compensate for the loss that they'll have to continue running the power grid. So this isn't already, like a tested and effective and resilient technology. And these kinds of nodes are really easy to set up. You don't need to know anything. If you just take it out of the box and plug it in, it will work. People can now use it to communicate with each other. And you can Bluetooth in from your phone and use the app to text, just like you can with a device like this. So you don't necessarily need a device like this. This just makes it a lot easier, right? So then there are sort of deeper levels we can go in terms of what we want to do with it. So with more advanced public nodes, we can incorporate weather stations with lots more data, right? And those are already using LoRa in many cases. They may not be using Meshtastic. There may be work we need to do to get them connected. But for these public nodes, the other big advantage is we can put larger antennas. We can put them on top of buildings where they can reach lots more people, right? We can put them with other repeaters from amateur radio clubs on top of hills and mountains. We can do all kinds of stuff like that. And one of the other things that's really easy to do is we can include a local offline copy of Wikipedia. So this is a Raspberry Pi 0W2, right? These are like 20 bucks. And it's very easy to include internet in a box. And you can give access to an entire local copy of Wikipedia, an entire local copy of the free open source alternative to many products like Google Maps. There's Appropedia. There are medical schools that are teaching people nursing in parts of the world where there's no access to internet, and they're running all of those schools, in some cases, off of a device like this, where people have netbooks and they're able to access all the information they need. So just for $20, you can include that in addition to everything else that these can already do.
Oh,
and,
monies.
And this also leads into the idea of BBS being something that we would want to integrate. And it's really easy once we have these more powerful devices like a Raspberry Pi serving things like these other types of content to also include something like a bulletin board service where you can text in and be like, hey, did anyone leave me a message? And it's like, yeah, here's one from this person, right? Okay, I want to leave one for them back when they get back online. Because one of the differences in having this kind of system is that if you're not both online, there's no server where your messages are waiting for you, right? So we can set those up. And these are also trustless systems, so we don't have to worry because it's end-to-end encrypted messages and we specify who it's for. and then they're able to decrypt it once they get it from the server. So all of these kinds of things are basically already implemented to some degree. It's just a question of bringing them together in these kinds of things that we can put together. And then these can also obviously do the weather data, just like the smaller ones. And if you follow my AI channel, you know that with a more powerful Raspberry Pi, you can also run large language models. And if you include retrieval augmented generation, you can very quickly imagine a situation where this local node on someone's roof, you can text it a complicated question during a disaster like, um, what should I do to make sure the water is okay? And it's like it looks through the UN's recommendations on that. It sends you those, and it's able to be like this super powerful search engine that is running on the same device and giving you information from Wikipedia, Appropedia, etc., related to the questions that you may have. And that really doesn't take a lot more. It's the same hardware that can do all of these things. So there's also a lot of people doing custom hardware development for devices that predate the TDEC. So ArmaChat is a really cool example, and this is open source hardware, so you can download the designs, you can change them, you can have them fabricated, they'll even put the parts on for you. And that led to a bunch of different kinds of similar devices that people were working on, including the Arma Watch, the ArmaChat Ergo, like those old, like early 2000s phones, right? And there are a bunch of different designs, different colors. And one of the things that that led to is that there's been this huge interest in developing custom hardware that does these integrations in better ways. So if we go back to this one, how can we, instead of having a Raspberry Pi and a LoRa node and a weather station with its own single board computer, like how could we put all of that on like one device? And so there are a bunch of projects, like for example, the TC2 channel, which is linked in the at the bottom of the gear list, where they built their own BBS, and they built a Meshtastic network, which is more of like an ATAC focus. So they're doing like this like tactical military Meshtastic thing of like telling the drones where to go in the backyard and stuff. And that's like very interesting. That's not exactly the goal here, right? And so there are aspects of that project that we can learn a lot from. There are aspects of that that we can sort of run with. Like they, for example, developed their own custom hardware that runs off of solar. It's designed to need way less power than a Raspberry Pi, but it can run the BBS software. It can't run internet in a box, right? But there are other projects. Forget the guy's name. It's also linked in the gear list. Did a whole so they implemented a version of Meshtastic that will run with a USB dongle on just a Raspberry Pi, so you don't need another single board computer to do Meshtastic. They also integrated, since it's on a Raspberry Pi, you can run at the same time all of these other things doing BBS, which they built in this project, which is linked. They also did there's plenty of room because they're using virtualization. There's plenty of room to also include internet in a box. So we could effectively include all the things that we're talking about on just one device, which is saves us a ton of money, but it's also going to use a lot less power. So there's a ton of opportunities here around sort of defining the use cases a little more maybe concretely, and then optimizing the build lists for, resilience, which is really tricky because if you want to run AI, it's really hard to do that off of a solar panel, right? You need a bunch of power compared to just forwarding messages, which is much easier, right? So there's a lot of work to do here, and there are a lot of interesting challenges to address together. And so I'm excited to see like what kind of other things people have worked on in terms of like your build list being different and sort of like what other use cases we might not have considered yet. And then if people are familiar with other projects that we haven't already mentioned that we can sort of include in the list. And also we're looking for like who wants to be involved in an ongoing conversation about this, because I'm guessing there are probably some people here who are kind of like, this is not really what I was expecting from this meeting, right? And so we have these other meetings coming up with kind of slightly different perspectives on the project. So
we did have a couple of questions that I think do relate specifically to our agenda, which is going to be The specifically the government intervention in the future, requiring licenses for LoRa, or they're selling out potentially some of the spectrum to private companies, and so that seems like a question, um, but like, we don't know what they're gonna do, and I think it is an issue with hardware. With software, it's like, oh, they banned our thing. We'll just make a new thing and it'll be fine. But with hardware, it's like, okay, we bought all this hardware and now none of us are allowed to use it. What do we do, right? And so I think that is an open question. Like, we don't have an answer for that right now. Open to thoughts. Um, but
It's
yeah.
tricky, but these are software-defined radios, so they can change to a different frequency if they needed to, which is just the software update. But also these are very low power radios, so in terms of like interference that they might give off, it's quite low.
Mhm.
So obviously we don't know what's going to happen, but there are millions of these devices in operation all over the world, and so it's unlikely that they're somehow going to all disappear, right?
Yeah.
Do you
Yeah.
mind if I add something? Do you mind if
Yeah.
I add something?
Go ahead.
Yeah, software-defined radios, like you said, they work basically in the fact that the hardware is not defining the frequency is defined in software. So, like I said, if they ban a certain portion of the 915 megahertz band, you can always recalibrate it to a different band, and it'll work just fine. So,
Okay. Yeah.
heads up.
Yeah.
Yeah.
Someone said, is the goal just for San Francisco? No. So like
Yeah.
we're the High Desert Institute, which way it's backwards. So it's a group that's interested in solving a problem, and a lot of these challenges that we're talking about in terms of like defining use cases and how do you optimize for that, it doesn't matter where you do that. And so like the goal here is to leverage the knowledge and skills and resources that exist here to solve a problem that will be able to apply everywhere.
Yeah, and the goal again is really to make sure that we have resilience in our ability to communicate, that we're able to communicate uncensored. Right now, I think that's one of the biggest challenges, is that it's very difficult to coordinate protests when they're all being censored from Google search and so on. So, having a Meshtastic node like to be able to communicate or coordinate between small communities with point to point would be ideal. Morgan, did you
Yeah,
have a
just curious on resilience. I mean, are we talking in like say a city of 500,000 people, like 5 nodes or like 60?
for like 500,000 people, you probably only need 10 to 15 nodes, honestly. It's not a lot of traffic. We're really just sending text. We're not sending like images. We're not sending a lot of voice packets. And so it should be fine. That's based off of some back of the envelope map or math. So
Yeah, I was just thinking for resilience's sake, like wasn't sure what that would look like.
yeah.
Thank you.
If you think about an area like, there's like San Francisco, 700,000 people in 7 by 7. And then there's an area like Dallas Fort Worth, which is many, many miles across, but it's got 11 million people in it. You probably need quite a few more nodes. So,
Yeah, DFW is big.
yeah. Yeah.
A lot of
So,
people are asking, is anyone else nearby them? The easiest way to find out who is nearby you that's using it is to send a public message like, hey, what's everyone doing? Right. And you can just reach everyone who's nearby you by sending a message to the public channel. And that's really the easiest way to find them.
I apologize. I don't know how to raise my hand in the chat, but I did have a couple questions regarding your BBS setup. If this is an okay time to ask.
We have a workshop about that. We don't have one yet. It's
Yeah.
something that we're talking about other in the workshop about that. We will be talking about all the projects that people are doing and sort of deciding how we want to do it.
Hardware aside, is I've been trying to look into a solution where essentially a like secure network channel like Matrix, which is like an open source chat platform. I don't know if you guys are aware of it, but it's kind of like a Discord, Signal, Telegram server that you can host yourself. Obviously, that's based off
Yeah.
of a Linux or operating system, but I was trying to find a way to enlarge a communication system that can't necessarily be reached by mesh. So, like, if a mesh could hit a BBS that could send matrix to another BBS, all of a sudden you could connect a very small community to a large community in a channel. I was just curious if you guys have explored any options of like how to get either across large distances or maybe implementing into smaller communities that may not have like direct access into a mesh.
We did. So that is going to be the night where we talk about the BBS. That's going to be we're solving the backhaul problem that night, which is how do we get from a local mesh over here to maybe another local mesh somewhere further away. Usually they use MQTT for that, and there are bridges between Matrix and MQTT that already exist. So we'll probably use those. But we're going to move on from that because we have a night.
Awesome. Yeah, I'll wait for that. That sounds great. Thank you.
There's also, in terms of hardware, there's a hardware conversation around those kinds of connections. So like, do we want to try to avoid using the public internet as much as possible, right? And that may not be like we're not gonna, create a radio link across like oceans. So if we want to be intercontinental, we may need to do that to some degree. But the main priority, the main goal is people who are near to each other to be able to communicate during a disaster. That's like number one. And then beyond that, like if we need to rely on the fragile internet to access like communications from San Francisco to Berlin, that's not really going to be important during a disaster in the same way. And so it's okay to have more fragile connections there. But we do also have technologies like APRS. There's a whole suite of APRS tools that's already built into all of these BBS systems that already exist. So they can send packet radio transmissions using these more high power, more long distance techniques that are already worldwide and established for doing that. So this is already a problem that there are a number of solutions to in terms of the hardware, and we can talk about the software part of that during the workshop about that. I'm trying to read all the messages.
Looking through, trying to read some things.
Yeah, we need a Carl prediction system. This is key.
Yeah,
Predicting Carl.
I've missed every astronomical event of the last like 6 months because Carl.
Oh
So,
yeah,
you know.
that's right. The eclipse. Carl came for the eclipse too.
Yeah, exactly. Just looking through. Yeah, there's a lot of bandwidth issues. I think the big thing is we're not trying to replace the public internet. That's like the key mindset to shift out of. We're really not. We're kind of trying to go back to remember the good old days of Usenet, and if you don't, that's fine and allowed. But if you don't remember them, it was just the text-based internet, and it was just people and it was not a lot of text too. You couldn't just be leaving a page and a half of stuff. So. We're kind of trying to go back to that. It's not that there won't be any ads on there, but like they'll probably be pretty constrained. It's a new thing. It'll take a while for corporations to kind of colonize it. So, but that said, the crypto bros have already tried to colonize LoRa with the Helium network.
But that's great because all of the hardware is $20 on eBay now.
Yeah.
And is not supported yet. Meshtastic is working on it. I have a whole stack of the Helium Ponzi scheme hardware for when it's implemented.
Yeah. Yeah, it's pretty capable hardware. It should run things. So if you're thinking you might run an internet in a box, or you might run an AI thing, the Helium nodes are actually pretty capable. And you can probably root them. I would be willing to bet money that Claude could root it, frankly. So
It's just the Raspberry Pi inside,
yeah,
or the ones that I bought.
yeah,
You just take out the SD card.
yeah.
Here's the thing too, though, is like if we're doing internet in a box, that's over Wi-Fi. So like sending text messages for 20 miles is like one side of the project, but then there's also like the local distribution of the library, right? So there's kind of the library of content being shared inside a community or a garden, right? And then there's connections to distant places or between people wherever they are, right? So we have the texting kind of protocol thing, and then we also have, like, if we're doing internet in a box, that's over Wi-Fi. So these also have obviously a Wi-Fi signal that they give off, and you just have to be near them or set up a repeater or use like a Yagi antenna or something to be able to access. Like if you want to stream video, that's a very different kind of problem from texting. But we do have a plan for that. It's just you need to be physically near, have access to those kinds of things, which is part of why we want to site them at community gardens, because we want people to know where community gardens are, show up and volunteer, and they're natural hubs of resources and communications during disasters. So
Yeah. Another group that might be good is your local library. They might let you plug in a Meshtastic node that like just provides wireless internet. So, talk to a librarian, make sure that they're not an afraid of technology librarian, but other than that, probably they're like, "Oh, great, public resources, wonderful."
I also think of it like Tor. Like a lot of these public libraries are hosting Tor nodes, and a lot of librarians are like the most aggressive, like anti-censorship, like let's give people access. Like this is exactly like every like I've had so many like enormously enthusiastic messages from librarians like give us one, right? So that'll be an easy sell.
Yeah, and they might have some of those things available as well too. Um, Then you might also think about donating some if you're wanting to set up a number of Meshtastic nodes in your area, donating some to your library's like tool library would allow people in your area, like potentially student organizers, to rent them. So that's a thing. Um, but yeah, so we did want to just keep posting if anybody has particular like let's try to scope it to hardware.
One of the questions that someone asked is about radiation. So the radiation that comes from radios is exactly the same thing as light. So the energy that is embodied in light is much less than the energy that is embodied in ionizing radiation from like nuclear weapons. Like it's a like half a dozen orders different, right?
Mhm.
So the power level of radio is significantly less than the power level of light, and the light that can give you a sunburn is like 1,600 or 1,000 times more powerful than radio. So radio is not it's not the same thing as nuclear radiation. It's just radio.
Yeah, the word radiation is sort of a overloaded term sometimes, but I linked a link to the EM frequency visualization. You can kind of see visible light is like right there with that other stuff. So it's literally light.
There's a couple of comments about how and where and at what height to install radios or antennas. And I made a very long video yesterday about antenna theory that goes into all the things that you need to know. So if you want more information, I just posted that yesterday.
There is an interactive simulator that's on, it's like site.meshtastic.org or something like that. Yeah, here we go. So won't spend too long on it, but there's the link in the chat. And it'll show you kind of, it does like a simulation of the like topographical like line of sight to other nodes, so you can kind of see what range you might get. Yeah, let's see. Yeah, height.
If the battery can be updated in the TDEC. So you can also get the TDEC without a case. It's very easy to put this is the same battery from the Heltex, right? So you just like plug it in, but you can get it with or without the case, and it's very easy. There's just a JST plug. Same for any little battery like this is going to come with that plug, and you just plug it in. So You can put a big one if you want, but it really doesn't use much power. These are super efficient.
Yeah. I feel like for a lot of this stuff, repurposing old hardware like that is for other mesh things. There are people trying to, turn a buck on the Meshtastic thing. Helium is your best bet, because people, bought a bunch of things thinking that they were going to make all kinds of money, and then they made $2 a month, and they were like, this $1,400 device is not worth it. I will sell it. Oh no, no one's buying it. All right, I will sell it for $60, and it's like a really nice spec. Those are going to be good for any heavy nodes. A couple of people were asking about the the repeaters and like messages that end up not getting delivered. So in your device, you can configure your node if you want to do this thing called store and forward, right? And it's like a setting on the individual channels, I believe, your device will store and forward. And it basically just like hangs on to messages that might be for another person and just continues to repeat them at a specific interval for a specific time frame. So that if somebody's like logged off for a second and then logs back on, they'll get stuff. Um, the amount of time that you keep messages is configurable. And like the 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 sort of spectrum between like store and forward node and like full BBS is kind of a spectrum. Like basically how long do you keep it? If you keep it indefinitely, it's a BBS, right? So that's one way to increase the robustness of the network is to run a store and forward node that has like a long thing on it, long time to live for all the messages. That'll help. But for that, you're going to need a node with some extra memory or a node with some disk space. And so these are the considerations you need to take into account. The thing that'll really balloon the cost of a Meshtastic node is having to put a like 128 gigabyte micro SD card in there. You don't need 128 gigabytes of text on the device unless you're running a BBS node, right? 16 gigabytes, a cheap $5 like card, or like you'll $20 for a pack of 4. You can probably get 16 gigabytes and like it's text, it really is not voice, it's really not images. So 16 gigs of text is nearly infinite text. Come on. So that would be my recommendation is you can have a very small node with just a little bit of space on it. Matt, what was
There's a
that?
couple more questions in the chat. Someone asked, is it the same as installing a CB antenna? The biggest difference there is going to be like a CB antenna is amplitude modulated, so it's all about the power, right? And a CB, this is a CB, okay, 4 watts. That is a lot of power, especially for amplitude modulated radio. You can run a really, really long cord to the antenna, and it's going to be fine. With something like a Meshtastic node, you have less than 1/4 of a watt and it's frequency modulated. So your sound to noise ratio is very important. You want to make sure that you have the shortest possible connection between the board and the antenna, which is tricky because it's like, well, if you put the antenna like up at the top of the pole, like with the board, like how do you update it, right? So one of the tricks is you run a USB cord down that you can plug into your laptop or whatever, and then just like wrap it in a plastic bag or something to keep it safe. But you want to make sure because the SNR issue, you have the shortest possible distance between the board and the antenna. That's the big difference from CP. And then someone asked about like nomads and van life. It does not confound the network. So you can choose whether or not you want to share your location when you set it up. But regardless, it's just set. There's no like routing protocol involved. It's just it hears a message, it repeats the message, and so it's not going to be a problem if people are moving around. I have one in my camper that's there's no problem. It's great because it's plugged in. It's like got a more stable antenna, and so it does a much better job than this does. And so this connects to that, and then that can reach much farther than this can. So having that kind of that's actually super helpful to have that sort of like base station in the vehicle with more power.
Yeah,
Matt,
I saw
that's a question.
somebody ask about using this stuff for like for other things, and yeah, we talked to some artists about the Meshtastic thing, and they were like, "Oh, I'm gonna use this for a really complicated giant light installation in Burning Man." I was like, "Oh, that would be actually very smart. You could make a really wide giant thing with that, so that's cool." I'm just trying to get to all the questions. Matt, you had your hand up for a minute. Go ahead and
Oh, thank you so much. Yeah, I'm wondering about you were mentioning the store and report or store and um resend or whatever, and I've got a node on my roof, solar powered, and then I'm in Santa Rosa where there's a ton of nodes. It's amazing. There's like 20 in my city. I love it. And then I know it's fantastic. And then I took a drive to Sacramento, and my node on my roof can talk to Sacramento. It seems like or up to Yuba City even. There's like, but I took a drive. And along the way, every time I kind of got to a new city, I would beep out a little message directly to my node on my roof. And most of them were not acknowledged. One of them was acknowledged, but when I got back home and checked, none of them went through. And I wonder if you think that's a bandwidth thing. Is my connection weird? And how would I diagnose that? Like looking at the hardware, like looking at my signal reports and all that stuff. Is there a way to figure out like what's happening, or am I just kind of in the dark? Thank you very much.
sometimes something that I've noticed is if it stores the location of a node relative to where you were when it found the node, later it doesn't like update that the node is really far away from you. So then it tends to send data out, and I don't know if it's like intelligent about its power usage or not. I don't know. But it does seem like sometimes it's like not updating with the new location of the node. So you might have been sending stuff out at old nodes. That said, if you were looking at the map, like, and it seemed like they were right near you and within range, then I don't have an explanation. And I don't know if anybody else does.
I think there's kind of a couple likely culprits. One of which is it doesn't necessarily, if you're moving, the like handshake protocol is kind of slow. Like it takes it a while to connect to new nodes and to notice them and stuff. So it may be that it's trying to send one to one that you've already passed or it's now out of range. But also there's the question of hops. The default number of hops that's allowed is I think 3. So that may not be enough to get to where you're trying to get to, but if you can reach certain, like all the amateur radio club repeaters, they set it much higher, so it's like 5, 7, and then that one, if you can reach Diablo Mountain, then you can much more easily reach between Sacramento or San Francisco. So it's, I think one of the key things is like being able to reach one of the big repeaters, but then also like you may just have passed it faster than you sent the message to it.
Last thing, so other people, of course, answer or ask questions, but it says to like limit the hops to around 3 or 4. I did turn it to 7 for a little bit. I didn't see any, but should I limit my number of hops, or does that?
Well, it's not you though; it's the ones that you're hopping through. So
Yeah, it's the nodes that you hop through. Sorry. I got 2 folks with their hands raised. You want to go first, Michael?
Yeah, thanks. Like I feel like I jumped straight in. I think I saw Future Initiative TikTok like an hour ago and said, "Oh, this sounds like something interesting." So I'm trying to get up to speed on everything, but to not take up too much time. I don't know if you guys have so there's really great off-the-shelf stuff, and using Meshtastic is fantastic. I don't know if you guys have kind of maybe looking forward. Hardware development team. I'm an engineer with a lot of experience in this kind of stuff. And so not really a question just now. I just want to know how to be able to like stay in touch and see if I can work with you guys on some of these kinds of projects.
I think one of the big goals for this meeting is to find people that are interested in doing that.
Yeah, exactly.
See what people want to do.
Yeah. Exactly. I'm gonna drop in the chat a link. A couple of folks just asked about a link to the hardware lists, and I've been accruing some of the suggestions that we've got in a list of lists. So I'll take a look at that most recent link. I also got a question: what is the longevity of the hardware when properly housed? That I'm an engineer, and so the number of ambiguities in that question make it very difficult for me to give you a straight answer. I'm so sorry. But like it depends on the housing and the hardware and the the conditions and how often you check it. It's not something that you just like, and then I set it free into the air and I let it go and I didn't worry about it ever again. Like it's very much not that. You have to kind of become an operator of this node. You're like a guardian of community resilience. So we are looking for people to volunteer to do that. Do you have to check it every day? No, it's like a cactus amount of maintenance, I would say. So if that's kind of what you're wondering, like, this High Desert Institute. Anyway. So um then yeah, did that answer questions on that? Otherwise, is anyone using Meshtastic with local AI? Yes, we are trying to set up an internet in a box thing. And we're going to talk about that in 2 weeks. And new question, isn't intercepting radio messages pretty common? Totally, but these are end-to-end encrypted. And so while you're able to see that nodes are talking, that you're not necessarily able to see what they are saying. Now, if you're just encrypting it with a blank key, like on the long fast channel, like it's not really end-to-end encrypted because everyone knows the key is blank. But if you want to do stuff like our coordinate channel is end-to-end encrypted with a real key, and so even if you were to intercept that message, you wouldn't be able to decrypt it, at least not now with all that stuff. So that's the difference between just like a walkie-talkie and Meshtastic, is that it's encrypted when we use Meshtastic. And then hopefully that's from sender to recipient. Also, we don't know on the LilyGo, there's not like existing malware that will compromise the LilyGo, but there's existing malware that will compromise your phone. So like one of the big problems has been, recommending, as a computer science professor and a cybersecurity professor, people are always like, what do I use to communicate securely? And I'm like, okay, for what threat model and all that stuff. But yeah, it's like impossible when you're talking about a cell phone, but these like kind of niche devices have not really been targeted by sophisticated threat actors yet. And so there aren't plug and play that we know of, exploits out. So yeah. Also, they don't execute code, and so like it's very hard to like beam an exploit to a LilyGo or something like that. You can't really there's not a lot of surface area to actually inject the exploit, so it should be fine for now, for a while.
It's actually read-only, right? You can only update it's just a big binary blob, and you can only update it when you boot it into a specific mode. And
yeah. We are going to talk about the BBSs, but again, in 2 weeks. Jackie, you had your hand up. What's up?
Yes. So I've got a number of friends in the service industry in various fields, restaurants, gas stations, things like that, who are aggressively anarchistic, shall we say, who have, I've mentioned Meshtastic stuff to them, and they have kind of propositioned various ideas of like, oh, well, I'll just open up the drinks machine when we do our nightly cleaning and just wire it into the power there so that it's hidden and doesn't need a solar and batteries just a backup, things like that. Should I dissuade them from that for like risk of having the network targeted or compromised? Like if the law gets after them, or is that something that
it's not
is
really
not
possible
really
to
a risk to the
compromise it.
network or movement at large?
Yeah, but also like putting it inside of something that's metal, it's not going to work because it's like a Faraday cage. But it's not possible for the network to be compromised.
Yeah.
Everything is end-to-end encrypted. It's just a repeater. So
Yeah. If they run a thing and the cops get that thing, the only thing that would get compromised is the keys to the channels that they were tuned into on that device. But
If
if
you put your keys on, right? Yeah.
and like encrypted packets of information will also be on that, like they could listen to it, but then they would have to decrypt those packets of information, and it's like AES 256, you're not gonna break it, so it should be fine. Or is it RSA? I don't remember which exact algorithm it was. But anyway, yeah. You can't like, so it's very similar to the Signal group chat problem, which we're all very aware of now, which is if you have one device in the group chat that is compromised by someone you didn't want to have that information, then the whole group chat is compromised, and it doesn't matter that it was end-to-end encrypted in the first place. So you know, if we all join a channel called the Resistance, and then one of our, you know, LilyGo nodes gets got, then that channel is compromised, and any messages that are sent after the compromise are available to the compromised node.
But that's
Which
also not the public ones that you're using. It's just your device that's sending and receiving the message, not the ones that it's hopping across. Those ones are, it doesn't matter if they're compromised.
exactly.
Someone
So
asked about like the encryption model. There's kind of three ways to send a message. You can send a blank, like a plain text message to everyone. There's like a public channel, or you can send one to a specific person, or you can send one to a specific topic, and the topic has a pre-shared key that you have to share with everyone that you want people to see it. So we have a couple of them that were set up during the first workshop. But then you could create one, like a private group chat for your friends, and you just have a QR code that you show to their device, and then they can also send and receive messages in that topic or channel. And then if one of those devices that has scanned the QR code is compromised, then they would get access to any future messages.
okay. I got somebody asking about 900 megahertz antennas. There are some really beefy ones out there. Uh, if anybody's got a link to a suggestion, that would be dope. If you could drop in the chat, that would be awesome.
It's also like more is not necessarily more. Like really big one is not necessarily going to work better. It's a specific size that is like ideal, which is 5/8 of the wavelength, which is like, what is it, like 9.1 inches or something, for 915 megahertz. So like more than that is not going to work better. It's going to be less good. And I just made a video explaining all the theory behind that, and the exceptions and the things that you need to keep in mind if you want to do that to maximize your antenna, you know. But
Yeah, more is not more. It's a lamp. So like, you know, is the brightest lamp necessarily the best lamp? I think we all, as neurodivergents, know that the overhead light is bad. So don't necessarily do that. Yeah. Simon, did you have questions?
I do. Can you hear me okay?
Mm-hmm.
So I unplugged my LilyGo, and I have a battery in it, 3,300 milliamps. And I unplugged it when the meeting started. Now I went down by 6% of battery power. So this wouldn't survive the night, right? Even so, if I were on solar power, I was wondering, like, what size battery would I need so I can assure, you know, even a cloudy day that I probably reach those 24 hours of service.
is that a T-deck? Or I mean, I'm sorry, is that a T-beam?
I'm not sure. When would I find that information?
Can you show it on the camera?
We set this up together at the workshop. It's one of the ones that you recommend on your parts list from the first workshop.
This one?
Girls, stop. Yes.
Yeah. Yeah.
So this one is 3,400 milliamp hours. If you want it to last better, the thing to do is change the profile. So the router profile, for example, is going to be very low power and wait for connection, and then it comes on and does what it needs to do, and then it goes to the very low power mode again. There's also repeater profile. The difference there is that the router is advertising its location and telemetry. The repeater is not, and that's an even lower power use profile. If it's in client mode, it's got like the Bluetooth on, the Wi-Fi on, waiting for your cell phone to try to connect to it. So it's going to use a lot more power. So you should be able to find the configuration settings for the radio to change the profile.
Yeah, it's on client mode, I think. That's why we set it up at the workshop when we were at the in San Francisco the other week. And then this antenna, does it also draw more power than the smaller antenna, I'm guessing, maybe, or
No,
does it not matter?
the power is the same for any antenna.
Okay. Cool, thank you.
Yeah.
Definitely. I see some folks asking, do you need a soldering iron or any like real electrical engineering stuff? No, this can be your my first having of a circuit board, plugging things together project. You don't need any real special equipment. But yeah, it mostly snaps together. There are a number of folks like, you know, talking about, sorry, I'm just trying to figure out what this is in response to. Don't do it on camera and don't get your prints on it and buy it with cash.
I think that was in response to Jackie.
Oh yeah.
Yeah, it work maybe.
Okay, recent DevCon exploit on the RPI. Sorry, did you mean to tag me, the Liz C? Are you talking about the Orbic exploit that does the stingray hunting? That's an EFF project, and so you can find that on EFF.org. Ray Hunter is what it's called, and it's all hardware versions of this, but it will only work in the United States. And I don't think, or sorry, the exploit on the RPI hardware. I'm forgetting what RPI even was.
Raspberry Pi.
Oh, the Raspberry Pi hardware. Oh, yeah. No, that one's fine. That was just like an Express IF, like dev commands. It was a nothing burger, not a big deal. I wouldn't worry too much about it. Okay, cool. Hold on, wait. Going off what you just said about hard to exploit, so stuff in a Stingray may not pick up a TDEC. Yeah, Stingray is not able to pick up Meshtastic at all. This is the reason why we're having people get these, is that a Stingray cannot get these. All Meshtastic nodes that connect to the mesh network are able to find the serial numbers of these devices. However, it's not a Stingray, and you can't prove that. That doesn't mean that that person was there. It was just like that device. A cell phone camera or a cell phone's a lot easier to say that was you. Someone else didn't have your cell phone, but like someone else had my radio, or I like dropped my radio there. I don't know. Like it's a lot easier to defend against that. So yeah.
I think the other important aspect too is like there's a plugin that was written for Meshtastic some years ago that is now included by default, but it's disabled unless you enable it, called PAX Counter. And it's an implementation of the algorithm that is used to scan all of the Bluetooth IDs and triangulate exactly where everyone is, and then how they're moving and where have they been, right? And it's trivially easy to do that. And it's an integrated feature that you can turn on, which is kind of like, that's scary, but also it's like everyone is doing that all the time. That's how AirTags work, right? And like knowing that that's possible shows us that we have this attack surface that we may not have been aware of, right? And then you're able to take steps to mitigate those kinds of risks and, not get disappeared off the street if you go to the wrong protest that becomes unpopular or whatever.
Yeah, so
don't bring any devices.
Yeah. Don't bring your devices to a protest under any circumstances. Yeah, it does create that security vulnerability. So if there's a way for you to get like another interface or a phone that you can directly plug in, I think this to like a Pixel with the USB-C, and I think they can connect over serial over the There's an Android thing that allows the
Yeah.
serial connection. I
You
have not
may need to root it.
but yeah.
But any computer can do that too. You can connect your computer via a cable instead of the Bluetooth, and it'll use less power, right? But that's the other like huge advantage with these, right? Like this comes with Bluetooth disabled and Wi-Fi disabled, and you just use this. You don't need to connect it. You don't need to pair it and expose yourself to these other vulnerabilities with Bluetooth and Wi-Fi and everything. So like, these are like it's hard to find any like negative to these. These are like really great.
Yeah. How literal is the term line of sight? It's not totally literal. It's pretty literal, but again, it's light. And so like if you think about a lamp like that's like behind my head, you could kind of see it flash on and off, right? Like you could tell that it was like, I don't know, here, let me do it like you know, right under the table. Like you could kind of see that. And so that's essentially what a radio, one of these radios is. It's like a lamp. So, yeah, I don't know if that helps, but
Can you see it from across town if like, well, how many other lamps are on, right?
right.
The
So,
analogy I like to use for that is like in The Magicians, the idea of circumstances, like what phase of the moon, like where's the nearest body of water, like everything affects it. It's too complicated. There's no way you're going to predict the answer. Yeah.
yeah, yeah, it's non-deterministic. Um, not using my existing discone. Yeah. Um, yeah, I mean, you can use existing stuff. You can also have a really beefy antenna, and it might help if there's not a lot of other stuff happening. Like if you're the only node in a long ways, like a big antenna might actually be helpful. But
And
yeah,
if you have an amateur radio license, you don't have to follow the same rules. So like if you're someone who wants to use more than a quarter of a watt and you get your license, like that's allowed. You just have to put your license number in the transmission, and that's built into the app to enable that. It is a crime to do that if you don't have one, right? But if you do get one, it's great. Like everybody should get one if you're interested in. If you're here, you're someone who probably should get an amateur radio license,
yeah,
and like you'll learn a lot, and you'll be able to increase the power level even more if you wanted to get a bigger. Yeah, yeah, there you go. And you would be able to use those higher power levels to take advantage of bigger antennas, and using more directional antennas with higher power levels, you can reach crazy distances. Like the record is hundreds of miles with one of these to send a text. So that's all possible if you get licensed. Yeah, the tech license is fine. You can use a tech license for that. And
I
it's like, you know, if you have a tech license, like you know what the rules are, right? So it's like use the smallest possible amount, and like you have to be able to justify that if somebody calls you in for breaking the rules, and then they're going to investigate. And there's a whole cottage industry of people trying to catch people breaking those rules and turn them in for bounties. And like people do that as a full-time job, so like they will catch you, right? So definitely like learn how to do it correctly if you want to do that, but it's an option.
about there are quite a few bounty hunters out there that make their money off bounty hunting.
I've done it.
You know,
You go to a festival and people are using amateur radios, and like security pisses you off, just call the FCC, right?
For radio, it's called fox hunting.
yeah,
Yeah.
yeah. Somebody asked, could we discuss profile types more? But I don't know what that means.
So like it's really complicated, but basically there are different profiles that you can set the modem to run in that will use different, will turn things on and off. Like for example, if you set it, if it's in client mode, the screen is on, taking power, the Wi-Fi is on, the Bluetooth is on, right? It's running the CPU all the time, constantly waiting for you to need it to do something. It's going to use a lot more power. But if you put it in one of these other modes, then it will start disabling things. It will stop advertising itself as a node if it's in repeater mode, and then all of those things are going to trim power utilization. Or, you know, like store and forward would be disabled in like a repeater profile, for example, because it doesn't need to be like saving things. It just needs to like listen and retransmit and then like wait for the next one, right? So there's like 20 profiles. It's really complicated. A lot of them are considered legacy at this point. But you know, I would read the documentation if you really want to get into the details on that. Paul, do you have a question or a comment?
Sorry, I just wanted to say there are two sets of profiles. There's the way it uses the network, which most people really should be stay in client because putting it in router can screw up the network, especially if you're just using a small unit. But the other thing is that there's modem profiles which set the speed. And at least in San Francisco right now, we're using long fast. That's the default that comes out. The overall Bay Area is using medium slow. I'm sorry, short. Sorry, I believe medium slow, which is actually faster than long fast.
We had a whole conversation before the first workshop about whether we should even try to explain that. We decided not to.
Yeah, leave it as the default that you get it from.
Yeah.
Is the short answer.
And you won't be able to reach people that are using the default if you change to one of the other ones too. So
yeah, oh, dope. Yeah, Liz C tested out the T-Deck plugged directly into Pixel 8 Pro and they see it no problem. So thanks, Liz team. Okay, somebody mentioned. Oh no, come on. I lost it. No, lost it. I'll find it again.
Yeah, did you want to explain the link?
Which link? Sorry, there's so many links.
We have a survey.
Yeah, we have a feedback survey. I dropped in the chat. I'll drop in the chat again. If you please fill it out. That's where you can sign up to hear more. If you're signed up on Luma, you'll also hear about the next one, and so that's a good place to sign up. And it will like text you and stuff. But if you don't want to worry about being texted, you can fill out your email on there and also give us feedback. So please do that, and that would be helpful for us. It looks like a bunch of folks dropped links to the antennas in the chat. The long fast versus short still.
Luma is the event, like RSVP system that we're using.
Yeah, exactly. I think I just sent the thing out to Greg only or somebody. Yeah, I'll drop the link to Luma in there just in case.
Someone said ordering a T-Beam and a T-Deck now. Do it.
Yeah, do it. We are going to order a bunch of node types. What we're trying to figure out is what is the cheapest per unit cost. And so I'd really love if anybody's got thoughts on that. If you've like looked this up or done some research, we have a certain amount of donations that are going to be only going towards buying radios for people. We want to get a certain number, I think, of the the internet in a box level nodes or store and forward and BBS nodes, but what is the cheapest per unit where we could send out to as many people as possible? That's like an open question. And then there's that second node type, which is that weather station node type. That's the one that has barometric pressure, temperature, and potentially a Geiger counter, which is a big thing because we don't have any massive radiation monitoring system, and we're not likely to get it here in the next few years. So it seems like it's maybe up to us specifically.
It's wild. I've had a Geiger counter logging in my backyard and also like the car for years, just like see what interesting things. And sometimes it's like, wow, the current ambient radiation level is like 5,000 times higher than the baseline. Like, why is that happening? And there's nothing in the news. There's no you can look at like air quality maps of like everybody has the sensors, right? There's nothing like that for nuclear radiation. It's like that's insane that we don't have that. And it's so easy to include in something like this. You just plug it into as another sensor, So another really cool idea. And then somebody also had the idea at the first workshop of integrating into those air quality sensors so that we can also have other kinds of like public health data that we can report. That would be cool.
Yeah, that would be cool.
Someone said, is there a way to sync with Purple Air? Yeah, I think like a lot of these networks would be eager to integrate with these kinds of networks of like what we're building. Someone asked where to have ongoing conversations about the Cyberpony Express. The Lore Keepers Guild is like the library, the broader project. There's another like a thread in there for Cyberpony Express.
Exactly. There's I would jump into the Discord. Do we have a link to that Discord that maybe you could drop in the
In my
chat?
bio. Yeah. Or if you go to actually, yeah,
Hi,
if you just do myname.com, it's there too.
oh,
That's what's in my bio.
EJTrowbridge.com. So there's this. Just dropping that in there. Yeah, there is a Kickstarter already on the Meshtastic like thing. 1 second. I'll see if I can grab you the link to that. But yeah, there's already there's already GoFundMe, yes, and it's restricted donations, so these can only be run yeah, there's that. So that's we've got some stuff built out. We'll probably get I'll probably do another donation push here in a little bit, but we are gonna do a mass node buy, and we are trying to figure out what is actually the best, like, build out, and like how many weather nodes can we get versus how many just like, radio nodes. What else?
And for people who want to work on doing the hardware planning, we have already allocated a budget to spend on the whatever we agreed to build. It will immediately get built, and then we'll set it up at community garden or wherever it's appropriate, depending on what we're building. And then we can immediately see how did it do, what can we improve. So we've already allocated funds for that. So if you fill out the survey and just explain that you want to help with that or join the Discord, then we can get it done.
Yeah. I don't know, what is Nibble? Cody, it seems like you've got a lot of background in this whole thing. What is Nibble?
Yeah, so hopefully you can hear me. The Nibble was a node that we created for Chaos Communication Congress that was supposed to be a soldering kit for beginners. And originally it was a step up from the AirWired version that we made that was really cheap but difficult and I would say even horrible to put together. So we made them and ran 3 different soldering workshops, and we've been also doing them with SoCal MeshNet in Southern California, just getting people to build their own nodes. And they have space available for GPS units and like I2C sensors, that sort of stuff. We're doing another revision to make them a bit more user-friendly because the resistors are admittedly a little bit tiny for a beginner soldering kit, but they've worked really well because they're designed to fit inside of a PVC pipe and just be a standalone node, kind of a beginner thing rather than anything with the screen and kind of low power, that sort of focus.
Thanks, that helps, yeah. Yeah, and then Adrian says, should I work on purchasing hardware now or wait until we get the revised list? It's really about what you want to do. If you just want to have a node so that you can do the communication yourself, then I would just use our original build out. It's like the cheapest one, or get the Helltech. If what you want to do is host a node, again, our original build out is actually pretty good for that. But you could wait until we do the group bulk buy, and then we could send you basically our final series of kits. It's really up to it's about what you want to actually do with your node. So yeah. Yes,
And it will work.
Go ahead.
It's just a question of if we can figure out a way to do it cheaper so we can do more of them,
Yeah. Yeah, I'd say for a final result, there are going to be 2 suggestions on hardware, one focused on a user needing to communicate and one for more permanent fixed node. Yeah, I don't know what flux.ai is.
It's like Stable Diffusion.
Oh, okay. Professional PCBs with AI assistance. Okay, cool, interesting. They probably would. Yeah. It's a forever link until we get rated again. Let's see. Yeah. Simple, cute Meshtastic node. Very awesome. I'll throw that in the chat or in the doc.
Someone asked about radiation sensors. So like you can get like a radiation, like a Geiger counter like this that's designed for like Arduino. These are like $30. And it's just gonna sit there and make the little tick tick sound, and it's gonna send you a ping to an interrupt on a Arduino pin or one of your pins on your Haltech or something, and you can count it, and then it is reported as telemetry in your, like when you see a node in the UI, it tells you like the GPS, it tells you like the temperature, you know, humidity, anything like that, and then it could also tell you the CPM of the Geiger counters reporting. So it's super easy to integrate.
So
the femtofox is the other thing I wanted to talk about. I forgot to talk about it. Someone asked about it. So the femtofox, you remember there's that group that did the BBS, the TC2 BBS is a big YouTube channel. It's more like the tactical ATAC kind of Meshtastic, right? Like targeting, you know, I'm not sure exactly what people actually use it for, but like in the military, it's used for like targeting drone strikes and stuff. And so there's a version of that that has been made public and ported to Meshtastic, which is a big focus of this group. And they also built their own BBS, which is great, but they got frustrated with the hardware requirements to run Python, so they put it onto this very small microcontroller with custom board that they developed so that they could use this microcontroller to host both Meshtastic and then also the BBS that they wrote, which is in, I think, Python, or maybe it's something more esoteric, I don't remember. But the PCB that they made, it was this product of like a huge number of hardware developers working in this Discord actually, and they came up with an open source hardware platform and an open source software platform to integrate all this stuff together. And you can get them on Etsy, and they're $65. But the problem from my perspective is like, this can do that for like a third of the price, right? So it can also do internet in a box at the same time too. And it can also run a large language model at the same time too, right? So Raspberry Pi can do a lot more than that at this point. The focus for them is not like delivering rich resources. The focus for them is it's definitely going to be able to run off of a small solar panel that you're going to put on top of a mountain and leave there and never have to go mess with it again, right? So that may not be true for this in the same way, right? Like you may need a larger solar panel. If it's in a community garden and you're able to deliver all of these rich resources, you know, $20 is nothing, right? So I think it's great. The femtofox is an amazing project. I think it's kind of it's a solution to a different problem. It seems to me, but I think there's a lot we can learn from them, like how the way that they developed and implemented the interface is very interesting. The way that they connected their BBS, a BBS is effectively a chatbot, right? So it's a node that you send a message to, like, do I have any messages? And it's like, yeah, here you go, right? So it's a chatbot that's integrating with a database, and you can run that on these like RPi 2040s or these femtofoxes. But if you want to do more than that, you really need more than that. So
I
I think that would be great, especially for one of the things I think maybe it was your idea to put like to have some nodes have some kind of like API type connection to like bigger nodes. So like if we have like one community garden in Oakland that has like the full AI node, and then the other ones, it doesn't necessarily need to be that fancy. They can kind of like ask that one for help with that kind of stuff, right? With those kinds of use cases, like a femtofox is perfect. But so would any Meshtastic node at that point, right?
I
So
see somebody's got a question about the Pine phone with no SIM card using a T-beam. I would recommend direct connection to the Pine phone rather than having your BLE on, just because the MAC address is probably findable. And so it can probably be traced back to you, and your Bluetooth screams your MAC address all the time. So,
they
uh,
also have their own LoRa thing that you can use too. Pine has a I don't know how to say it. It's like Pine DIO, like Pinedio, and it's from Pine 64. It's like an open source LoRa platform. And actually, it's one of the ones that's supported by Meshtastic natively for their Linux client. So if you wanted to use the Linux version of Meshtastic, that's one of the hardware radios that is officially supported. The Pine 64 one.
Paul has some thoughts about which specific transceivers there are. And so that's a good note. Lower number is better.
Someone asked for the link. It's on the gear list.
Oh, great. Yeah. So I'm just like adding a bunch of notes, just like anything that seems pertinent. And then we'll kind of clean it up at the end. Does anyone have any like debate sort of things where they're like, I'm not sure this or that, that they wanted to bring up? I also want to get to the people who have their hands raised. Alex? Morin?
Oh, yeah, thank you. I heard the question of radiation detection come up. I worked in the applied nuclear physics group at UC Berkeley for a number of years. So there's DoseNet. I mean, this may be old information, but there's DoseNet, and there was an Array of Things project in Chicago, both of which. So DoseNet is explicitly for detecting like radiation that happens after rainfall. There's generally spikes in people's basements, but then Array of Things is like a multi-sensor network that was distributed all the way across all of Chicago, and I think they were using like 2G or something like that, but they also had some of our spectrometers embedded in them.
Okay, that's pretty helpful to know. Yes. Matt.
What were they using those?
DoseNet and Array of Things. What was the Array of Things for? Is that what the question was?
The spectrometer.
The gamma ray spectrometers were to measure background radiation, but also what happens after rainfall is you get radioactive gases come out of the walls of your basement, and so when it rains, it can be toxic, and so a lot of the radiation measuring is specifically for that.
What kind of unit cost was there for that, for building a spectrometer node like that?
They can be pretty. I mean, you can get, depending on the resolution you want. They can be really cheap. Like I've worked with like little USB spectrometers where you're actually trying to localize and like do your ray tracing and back projection, and you want to identify a particular isotope. You need like something more expensive, in which that goes into whatever up to infinity as far as prices.
Yeah, that's interesting.
Yeah, for those of you who are like wondering, there's connecting the smartphones to the Meshtastic radios. Yeah, it would be ideal to have a standalone device, and like the LilyGo T-Deck is a standalone device. It would be better not to use your phone, but the interface for a lot of the radios is not super usable without something, so it's why people tend to do it. And Chris, what was your?
Hi, hello. Questions for CJ actually, maybe more so Liz too, with the Internet Box kind of project. I actually have been thinking about that on my own, and I was like actually starting a project with ESP32s to use like the batteries that you can reuse from smart cars and the cell phone batteries from like radio clickers. Because I was thinking like if the grid was to go down, how are you going to power all these devices if you're in bulk doing it? How are we going to replace the batteries? Have you taken into consideration like power sources at scale that's like able to be scavenged, I guess, or Frankenstein out of other things?
We've been focusing mostly on solar, with some battery backup. And so we are trying to build out some fairly large enough, you know, arrays of batteries so that you can go overnight and recharge with solar. But beyond that, yeah, it's like, hooking into the grid.
I think
But
with any kind of disaster preparedness, there's kind of like an upper limit, right? Like if there's a Carrington event, we're fucked. It doesn't matter, right?
hmm,
Like if we get hit with like a gamma ray burst, like it doesn't matter. Um,
I was
but
thinking too more so for like internet in a box is like rural communities in Africa. So like
right.
if all of these cars that we don't like now are going to be in junkyards, they have viable batteries that made by Panasonic have like 10,000 cycles, which is
yeah,
like far greater than publicly available. So like those could be repurposed for a really long time. So
Yeah.
if people are familiar with Low Tech Magazine, it's a blog that's run off of a Raspberry Pi that's powered by a solar panel, and it's sometimes it goes down because they run out of battery, right? And it tells you like the battery on the top. It's really cool. It's called Low Tech Magazine, and they have a big focus on like historical technologies that are easy to make yourself at home that don't require like rare earths and stuff. And one of them is solar panels, where it's actually quite easy to make solar panels with scavenged materials with like asphalt and tin and like scraps of metal that are put together in a certain way. You can make photovoltaic panels that will work, that will produce in the order of hundreds of watts in a small area. The efficiency is not as good as what you're going to get at the store, but it's totally possible to do that without any of these products, right? So that's always an option. And the other thing that's really cool is because there's this, it has now been demonstrated that any DAC, any digital analog converter, any PWM pin on any microcontroller or CPU is capable of transmitting valid LoRa packets without a discrete radio. So you can just send the right wave through the trace on any board from any chip, and it can come out as a LoRa packet, right? So you don't even need a LoRa radio to send messages with LoRa, to potentially receive messages with LoRa. It's been demonstrated that you can do that with any digital analog converter, any with a range of about a kilometer, potentially. I mean, circumstances, but yeah. Any Raspberry Pi, any Arduino, any of these chips has analog pins, and those
Mhm.
analog pins can simply go to a piece of metal it doesn't even have to be the correct length. There's an
Mhm.
ideal length, but anything will work.
Mhm.
They can transmit LoRa messages that way. It's pretty wild.
Yeah. Can't receive LoRa messages that way, but they can transmit them. Kelly asked if we could secure the T deck so that the 5.0 can't compel you to unlock. Um, no, not really. You can you can wipe it. If you get pulled over, like begin the wipe procedure like immediately. But again, if you're acting as a router node, you are not compromising. You cannot compromise the network by acting as a router and having the router be compromised. That's just not how that will work.
It
Uh,
is possible though that since it's an open source project, we could simply add that feature, right? Like in an afternoon, we could have an option that you could turn on that would require a password to decrypt the keys in order to be able to use it. That's
mhm.
something that we could feasibly add to the software.
Yeah. You can fry the device without power if you power on the node without the antenna attached. Yes. It's we did it a couple of times and it didn't fry the device. That doesn't mean it's probably not a problem, but we were bad and did it and it was fine. So, but yeah, don't do it. Yeah, there's not really a way to remotely erase keys. But you could program that in. I think ATAC has a different I think ATAC has something built into that so that you can remotely disable a node, but somebody has to be a leader node for that, and that's like in the config. I have not dug into the config of ATAC, so you know.
That also introduces like a centralized topography, like then you have a single point of failure that everyone has to be able to reach in order to validate that they can still use the key, right? So it's tricky. The other thing though is they wouldn't be able to get, if someone got your keys, they wouldn't be able to get your like past messages. They would only be able to get new messages. So
Yeah. Did you somebody set up a thing to where you can remove keys with remotely? Was that you?
yeah.
That you? Okay, somebody in the room with me.
Who's,
Show it.
is Lex? Who is Lex?
Let's get there. I'm not on the. Are you in the thing?
Someone is asking to present. Lex. Do you know them? Okay.
They're behind me and they're in the room. Yeah. Yeah. Also, you're muted. It looks like, yeah. I mean, basically, you do kind of need like a protocol for when people get pulled over. That is like the biggest security risk about this whole thing is just that somebody's node gets compromised and it's a group of people who've shared keys and they're continuing to coordinate. If your device gets compromised and your stuff is on the device, like the history of the chat, then that, of course, that history of the chat is compromised. The 5.0 cannot compel you to tell them your password. There's not like a special secret protection for smartphones that then doesn't apply in other cases. They can't make you give them the password. So as long as there is some sort of login password or some sort of like access control that you can put in, does not apply to biometrics. So your what's the one? Fingerprints, eyes, face, whatever it is, the cops will just hold your face up, hold the phone up to your face the same way. But yeah. Yeah, it would be helpful. That would be helpful. Yeah, what do you have? What do you got? Yeah, editing Meshtastic stuff is pretty decent. So you have like a panic module. Yeah. Sorry, one sec. Alex, we can't hear you. Oh, all right, now you don't have audio. So, all right, I'll announce. I don't know, it sounds like you made a thing that will change change the firmware? You just made like an app?
If you push the button 8 times, it will delete the keys.
Yeah.
That's
Push
cool.
button 8 times, deletes the keys. Yeah. That's essentially what you want. By the way, you can set one of those up on your phone, like using Siri shortcuts. I don't know about the one for Android, but I know that Siri shortcuts can do stuff like wipe an app, uninstall an app, delete a file, delete a key, whatever it is.
That's cool.
Yeah. No, that's great. Okay, yeah. So, like, yeah, Claude can do it, y'all. Claude can definitely do it. Thanks for showing us. Yeah, no, it's definitely a thing. Edit the source code. Like, it's all open source. You can download the source code from meshtastic.org's GitHub as well. Sorry, I'm just like, yeah, option to have a kill code. Yeah, that was what we were just talking about, Morgan, was
Yeah, I wasn't sure if maybe just having that not just for your own device, but say there's 6 people in a group, just, hey, if I send 5, 6, 7, 8 to the group, it just deletes all record of it from everyone's thing.
Yeah. Honestly, it's C++, I think, in the firmware. Is that true? There's also there's Python bindings on C. So you should be able to write either a Python script or a C++ script. Again, Claude will just do it if you set up mono-context protocol. So,
Yay, Claude.
back, you know.
One that I like the idea of teaching people to stomp their node at the surprise security party.
Yeah, that's true.
You
Surprise
stomp
party.
it as long as you break the chip. It's probably
Yeah. Totally fine. Yeah. What is it? Oh, oh yeah, there was an app, wasn't it? Yeah, I mean, the other thing that you should probably talk about is it's really about protocols, having a protocol with your friends, right? Like if you're on a Meshtastic, I don't know, if you're trying to go do a direct action of some sort and everyone's decided we're going to use Meshtastic and you're all coordinated, you need to know about what happens when shit goes sideways. You need to have like just a standard protocol so that there's no questions of just like, oh, this thing has happened, and so I know from the flowchart that I do this immediately. Because when scary stuff happens, your brain shuts straight down. The prefrontal cortex just goes away. They cut power to the bridge, and then your amygdala is like, I am the prefrontal cortex now, and it will not do all the things that you wanted it to do. So if you have like a very short list of like 3 things, 4 things, that's about all you can really remember. It's just like, delete keys, delete history, and that kind of stuff. And so if you can script that, it's even better. Usually because there's like 3 things you need to do or 5 things you need to do when the cops show up and start taking people's devices. So,
but the best OPSEC is always just don't bring it. Don't bring any devices.
yeah. Yeah, do you need to coordinate at the event? Really? Like realistically, something that is more robust is to have a very small number of people coordinating. They're basically just sharing lookout information, the positions of law enforcement, essentially, and the relative concentration of law enforcement, and whether or not there are any vehicles rounding people up in some way. And so, um, just having like 5 people in the entire crowd that are able to get messages to each other without a stingray being involved is great. That said, for any large enough direct action, there's just gonna be people there that brought their cell phones. Like that's just statistically what's going to have happened, right? So are you gonna be the only person in the crowd with some ability to communicate? For sure, no. But being able to, like, if you're able to, for example, use one of these, alert the crowd that there is a stingray present and that they are being logged and tracked. Um, you're going to have people turning off their phones, and then they're going to suddenly be needing a bunch of information, and they may come to you if you're the one who's yelling about the stingray. So being ready with the Meshtastic nodes at a direct action to coordinate with other people that may be on doing the same thing, like trying to capture stingrays in the same medium-sized area, can be like a huge help to the group. So yeah. I see like walkie-talkies with encrypted DMR. Yes. Yeah, regular radio with code words does work for that. They'll figure out your code words. They are also able to hear your conversations. So like, I mean, uh, it's hard. It's pretty easy to figure out a code word. Like if somebody says, there's pork and beans in the area or something, like they're gonna figure it out, like like them having entered the area and then somebody says a word over the walkie-talkie, like obviously that's the code word. So that it's hard to do something. You can't really do encryption in plain sight, kind of for the same reason that like the topic modeling problem with encryption is a problem, so
I've got a slightly off topic, but kind of related to your area of expertise question, Liz.
yeah, go ahead.
Is
Yeah.
there a operating system that's open source you'd recommend that's like super secure and encrypted,
Uh,
like that would run off of just a SIM card?
oh, that
Or I
what?
guess not exclusively a SIM card, but like I've got a couple of old Android phones that I was thinking about like, hey, I could get a secure OS for this and this could be a good burner.
Graphene would be decent. Like graphene.
Graphene?
Yeah.
Okay.
Oh, graphene's only for pixels. There's a Tails mobile, but I don't know if it's good. I haven't tried it. I don't know.
Well, pixels is what I've got.
Yeah. If you got pixels, then graphene's the one. Kali's got a lot of tools for wiping your thing, but I hadn't played with Tails in a while, and I downloaded and played with it the other day, and I was like, oh yeah, Tails on a USB is what you want, really. So, yeah.
Is Tails a tool or an OS?
It's an OS, yeah.
Thank you.
Yeah.
An OS is designed to like burn itself when you turn it off.
Yeah, burn after reading OS.
It runs in the RAM.
Yeah. That said, you're still having to deal with management engine and PSP. So, I mean, but you can run it on a USB stick on like a Raspberry Pi, and those are usually not very well monitored. So, it's really about getting out of the dragnet in those situations, usually.
But I really am primarily focused on disaster preparedness.
Yeah, exactly.
There are lots of these other things that it's also good for.
Yeah.
But that's where we're focused mostly.
Waiting on my TDEC Plus. Are there security tools to open the device? To open the device, like as in to like root it or something, the firmware is open, so you can root and do whatever it is that you want to do. And the firmware is like there, you just want to build from source and be in the development version, and then you don't have to open it. It's already open. If they have physical access to your device like a TDEC, can they access the data via serial? Yes, but not again. Not the encrypted data. Like if you're just forwarding, no, they can't. Yeah, it's not put on it. Okay. Cubes, yeah, Cubes is Cubes mobile? Anybody know? A reasonably secure operating systems. Okay. Yeah, looks like no. Looks like it's workstations. Okay, what else we got? Graphene, walkie-talkies, disasters. Yeah, some of us. Yeah. Yeah. I mean, I don't really recommend code words. Code words are I don't recommend them. They're pretty figure outable. It works in a movie, but it's really like my mom is making spaghetti for dinner. Like no one's walkie-talkieing that information. So there's like a game theoretical layer to the whole thing. But anyway,
Someone said for a newbie, where's the best place to first start? Get one of these. It's the TDEC Plus. It's on top of the build list, and it can do everything that any of them can do. Maybe not quite as well, but it has all the features built in. You can send messages, you can receive messages, you can see where your friends are, you can take advantage of the network of them. It's a great place to start.
Yeah. If you're new, your first thing is just buy a node and set it up. That would be if you're new, that's the next thing. Yeah, memes still. Yeah, honestly, security by obscurity is not real. It's fake, it's made up, it's not a real thing. And that's what code words are, is security by obscurity. There's no way they could figure out what I'm talking about. They actually don't need to. The fact that you sent a message is kind of enough for them to like figure out what's going on. And so if you're talking in the open, but you're talking about gummy bears, like they will figure it out. They're not going to be confounded by the obscurity with which you speak.
Larry said Burning Man. People talking on the loudspeaker trying to use the code word, and it's like, everybody knows what you're talking about.
Yeah. Even if the code word is super innocuous. Tortillas. Okay, well, but still, why are you messaging the radio about tortillas? What just happened prior to the message about tortillas coming out? Okay, that's what tortillas means. Like it's too easy to work out, you know? It's kind of like when you were a kid, remember when your parents would like spell things or speak in pig Latin and they were like, it's time for, DINNER, make sure they take a BATH, and you're like, uh-oh, they're talking about things I need to know about. And they would tag information as interesting by doing that. So when you get into a direct action, talk about a tortilla, like they're just gonna be like, what? That's obviously an interesting thing. So
Someone asked what's the difference between the TDEC and the TDEC Plus. This is the TDEC Plus. This is the TDEC. It just doesn't have a case.
Oh,
it's the same.
Yeah. The Plus has a case.
You can print one and it'll be cheaper, but just get the nice one, in my opinion.
Yeah.
GPS, that's right. I forgot. The Plus has GPS. The regular one does not have GPS. And I found out the plug, it still has the plug, but it doesn't work because they're using the pins for the GPS. So this plug is not useful.
Oh. Yeah, I don't know why that's there. Yeah, the T-Watch, you like it? I think CJ has the T-Watch. It's dope.
I mean, really, it's only useful for receiving messages. There's not really like a way to send messages from it. You could connect it to Bluetooth. One of the things that's cool is it does have a compass that points to like where your friend is and how far away they are. Like that's pretty cool. But it just shows you everyone. So like however many people it can see, it shows you like where are they in what direction. So you may struggle to actually identify which one is your friend. But if you're just trying to receive messages like notifications from some system that you have set up somewhere doing something, it's great for that, or just to use as a node in general. But I don't know. I've only worn it once, and it was at the previous workshop.
So, did we get everybody's question answered? Did everyone drop their build lists in the chat if you built out a build list?
And make sure to fill out the survey if you want to participate in future stuff.
Yeah, I feel like we got a lot of good stuff done. We got a lot of good recommendations. We're going to collate the recommendations. We'll send them out at the end. Here's the link again to that survey. So please let me know. So glad you were able to attend. Thanks for coming, Cody. You gave a lot of really great recommendations. I'm very thankful to everyone who asked questions and also had answers for the questions that I couldn't answer. That was very team effort. I appreciate it. Yeah.
This will be on YouTube, so
it will be.
We'll post the links for that.
Yeah, tough.
We might edit some of it out.
Should be good. Yeah. So next week, what we're gonna do is talk about citing. We're going to talk about where do we need to put stuff. So in order to prep for that, I'll send out materials for how to prep for that, but you can look at the site.meshtastic.org planner and kind of look in your area. You also probably want to look at MeshMap. We're trying to make this whole process pretty sustainable. It's a lot of little details. If we just dumped a whole bunch of action steps and stuff like that on you and didn't give everybody time to get their questions answered, it would probably not go super well and nobody would complete the thing. But, also everyone's kind of got their own ideas, their own thoughts, and there's a lot of experts in this room. Like there's a lot of experts in this room. So I'm really glad that we can crowdsource this stuff. If anything you want to leave in the feedback would be great. Oh yeah, here's meshmap.net. Here's the link. Pow. Yeah. So many tabs. It's so many tabs, y'all. I'm thrilled that we got a recording of this and also the chat. I'm saving the chat locally as well because there's lots of links. And I think you'll have a list at the end. Yeah.
And then the next one after that is about the BBS project. So 2 weeks.
Yeah, exactly.
And
Oh,
doing LLMs with RAG.
Is it 2 weeks? Yeah.
So,
No, I think it's next week. It's like the 3rd, right? Which
next week is citing. And then
yeah, sorry, yeah.
is the BBS.
Citing and then BBS, yes. And if you are near New York, you know, there are Meshtastic networks and groups out there, but we could use a lot of them. There are a number of student unions in and around New York that could probably use your specific help. I would reach out to them. And if anybody is in the New York area, please send me an email at liz@themultiverse.school. I have some kids from a particular set of universities that might need some help setting up some disaster preparedness stuff. And so if you're down to help with that, I'm looking for help. Yeah, that's awesome. Yeah. So help me out. That'll be good. Cool. Drop me an email, please. All right.
Cool.
Cool.
See you guys next week.
Yeah, see you next week. All right. Thanks for coming. See ya.
This is great. Thank you.
Yeah, thank you so much.
Thanks,
Yeah, thanks to
everyone.
you guys.
Well done,
Thank you
guys.
so much. Bye.
Thank you.
Thank
Bye.
you so much.
Hooray.
See you guys in the airwave.
See ya.
Have a great night. Thank you.
Yeah, thanks. Of course. Yeah.
It was a lot of people. It was like more than the RCPs. So that's good.
All right. I guess we're still recording. People are filing out.